Okay, so it says the Wechsler Adult Intelligence Scale, also known as the WAIS, is a common IQ test for adults and children. The distribution of the WAIS scores for persons over 16 years of age is approximately normal, with a mean of 100 and a standard deviation of 15. Let X bar be the mean WAIS score in a random sample of 10 people over 16 years of age. Now, there's a distractor in this. We do need this information, like if you're actually doing evaluations of people and all that kind of stuff in psychology, but we actually do not care about this number 16. That is a distractor. That 16 has nothing to do with the math of this problem. It has to do with the application of the actual test. So whenever I see a distractor like that, I usually cross it out because that keeps me from accidentally using that number anywhere in my problem. Now, if we were doing the whole make sure there's more than 30 people and is it normal, this is important. Now, we're not doing that here, but if we were, that would show us, yes, it's normal. Mean of 100 and standard deviation, that is important. And it says a random sample of 10 people. I did kind of cross that over, but there you go. So, A, calculate the mean and standard deviation of the sampling distribution of X bar. So we use our funky little letter that looks kind of like a cursive U, and we do X bar, all right, and we say that's 100. That's our sampling distribution mean, okay? Then we're going to do our little curly QO, ox, all right, and that's that very simple formula, which is the standard deviation over the square root of n, which in this case is only 10. So again, if we were saying, hey, do we have enough information? With only 10 people, we would say, hey, proceed with caution, because we don't have 30 people. But we're not doing that here. If we do the math here, we get the number 4.74. Okay? So that's it. That's all you do for part A. You just say, put the funky symbol equals 100. Ox is the standard deviation divided by square root of the number. Moving on to part B. Interpret the standard deviation from part A. This is one of those rote statements we use every time, and we just fill in the blank. So we say this every time. On average, that's how we start this. If I could spell, average. Okay, and then you just look at this. What is it talking about? Here it's talking about test scores. It could be weight of tomatoes, whatever. Right here it's talking about test scores. So on average, test scores. So this part here is the part we fill in the blank. And then here's the standard part, deviate. And then here's the fill in the blank part, 4.74 points. Okay, so that's another fill in the blank, and that comes from right here. That is the number that we get from the ox formula. Okay? So on average, fill in the blank, deviate, fill in the blank from the mean. That's it. Very easy statement. So we were talking about weight of tomatoes. We would say on average, tomato weight deviates 2.85 from the mean. Okay? You just fill in the blank with whatever you're talking about in the problem. Now it says, find the probability the average WAIS score is 105 or greater for a random sample of 10 people over 16 years of age. Okay, and draw a pick 2. So we need to find our z-score first. And remember, our z-score, I'll put the actual rough formula, is our actual minus our mean divided by the standard deviation. Okay, so in this case, we're going to use that new ox number we had. So our z-score is, we got this, 105. Minus our mean, which if we go back up to A was 100, divided by the standard deviation. Now remember, we're not talking about the standard deviation of 15 on the overall. We're talking about within the sample. That's what this score is. Very important. Okay? In the earlier chapter, we would have done, a formula using the 15, but this is a different topic. We're talking about sampling distribution of means. So this is the number we use. And when we crunch that number on a calculator, it is 1.05. Okay? So you're just going to make a rough bell curve. All right? You're going to put your 100 here. All right? Now, technically, I'm not going to be really picky about this. I would just go 1, 1, 2, 2, 3, 3. Technically, if I want to be really accurate about this, you would add 4.74, 4.74, and put those numbers here. I don't need you to do that. No big deal. And you would subtract 4.74, but it doesn't really matter. We're just doing a rough sketch of the data. So if you think about it, we're looking at a z-square of 1.05, and we're looking at greater than that. Well, if my if this line right here is 1 standard deviation, then 1.05 is going to be really close to that, almost on top of it, and I'm going this way. And that's all I need. That's all I need for a picture, okay, is for you just to, put it somewhere along there, okay, something like that, right? So, for example, let's say this number, the z-score was 2.37. Then you would go somewhere around here and put it. Now, don't draw that in, but you go somewhere past 2, between 2 and 3. Not going to measure it, just somewhere, and you would color it in like this. So, just for example, that's what we're talking about. All right. So now all we do is, so we go to our stapplet we've been doing since the beginning. We don't care what this is. We don't have to put 100 in here, 4.7. We just put 0 and 1, okay? Because it doesn't matter because it's all relative. We're looking for a value greater than, because it said greater than, and we're going to put in here 1.05. Hit enter, and there's my area. So when I come back to my problem that I'm working on, I would write, you could, if you want to put the decimal, you can, or if you just want to write 14.69%, okay, because it asks for a probability, you can just copy right off of the stapplet, 14.69%. And that's it. That's all we're doing. Okay, so we'll move on to number 2. So it says a pediatrician. Let me make sure. I think it's counting. Yep, it's counting. All right. Pediatrician has found that the heights of their patients, okay, so this is how we're talking about height, follow a normal distribution with a mean of 40, okay, and a standard deviation of 10.2 inches. So this is some important information. Each day, the doctor sees 15 patients. That's also important, which can be considered a representative sample of the doctor's patients. Right there, again, if we were doing conditions, this would tell us we're good. We got a nice random sample. Each of the heights is recorded and the mean is calculated. So again, if this problem said a pediatrician who sees ages 8 to 15, that would be a distracting number. We would cross it out because we don't care about that. We're going to do the same thing we just did. Okay, so we draw our our funky U and put X bar next to it, and that was 40. That was our mean. Then we write X with a little line over it, right? And then we do our little calculations, which is very simple. It's the standard deviation divided by the square root of the number of patients. And again, with only 15 patients, if we were checking conditions, not really enough. Proceed with caution. We crunch that number, and we get 2.63. Okay? So that's our new standard deviation we're working with. So interpret, we're going to use that same statement. On average, you say the same thing every time. And now we fill in the blank. Heights. If you want to say children's heights, whatever. Deviate. Fill in the blank, and we just copy that number right there. That's where it came from. 2.63 inches. I'll put that in as part of the fill in the blank. And then we just write from the norm. Nothing new. From the norm. It says find the probability a sample size of 15 has a mean height of less than, that's important, 38.5 inches. All right. So sometimes what I'll do, I didn't do on the previous one, I'm sorry. I would just do a really quick like reminder to myself, less than 38.5. You know, up here, I didn't do this, but I might remind myself greater than 105. Just, you know, just so I remember which way to shade. And when I go to my applet, which way to go left or right. Okay. Then I'm going to do my z-score. Very simple calculation. It's my actual, which is 38.5, minus my mean. And hopefully right at the bat, you're already thinking, hey, 38.5 is less than 40, which means that's going to be a negative z. So this is going to be on the left side of the middle. Hopefully you're that far in here that you've got that kind of in your head. And then you're just going to put that new number that we got from up here, way at the beginning in part A, and we're just going to crunch the numbers. And that's going to give me a z-score of negative 0.57. I'm going to do my wonderfully artistic bell curve. I'm going to put a line in the middle. I am going to put the 40 here just for a reference. But then I'm going to go 1, 1, 2, 2, 3, 3. Okay? Not great artwork, not very exact. And I'm going to say, hey, negative 0.57. That's between 0 and negative 1. So it's going to be somewhere in here. Again, a little bit closer to negative 1. Not much. I'm not going to measure it. It's going to be like here. I'll do a different color just to kind of emphasize it. So there's going to be my negative 0.57, right? In fact, I'll just remind you that's where it came from. And I remember I'm going less than, so I'm going to shade this way. Then I just go to my handy dandy applet. This time I'm going to change it to the left of. I'm going to put in, don't forget the negative, 0.57. Calculate area, there it is, 28.43%. 28.43%. That is the probability that it's less than this number. If you wanted to put this, you can. I don't know why I put the extra dot in there. It's not needed, but it's the same thing. And that's all you are doing.